Hello viewers, we are going to study the topic firefighting today. It is one of the topics under household equipment. What under firefighting? Why should one fight fire? We are aware that in our day-to-day life, we come across several fire accidents, fire disasters. It can be furniture at home, it can be something like a cylinder in the kitchen, it can be electronic gadgets, devices such as computers, refrigerators, so on and so forth. How to fight the fire that occurs all of a sudden, and what are the preventive measures? What are the precautionary measures that one should take? We have got several fire extinguishers to stop fire. There are several bylaws that have been laid down, and even there are specific measurements about staircases, lifts, construction of buildings, as well as several fire safety precautionary measures. Let us study them one by one. I am going to begin with the first one, that is fire elements and classes of fire. The four fire elements as per fire tetrahedron to start and sustain a fire or flame are: number one, reducing agent, fuel, substance burned in the combustion process. The most common fuels contain carbon along with combinations of hydrogen and oxygen. The second one is heat. It is the energy component of the fire tetrahedron. Heat in contact with fuel energizes ignition, resulting in continuous production and ignition of fuel vapors, causing the vaporization of solid and liquid fuels. Let us see the third one, that is oxidizing agent, oxygen. An oxidizing agent is a material or substance that, when the proper conditions exist, will release gases, including oxygen. This is crucial to the sustainment of a flame or a fire. The fourth one, chemical reaction. The self-sustained complex chemical chain reaction requiring a fuel, an oxidizer, and heat energy to come together in a very specific way. Let us see what are the various classes of fire. Class A fires. The usual control method of Class A fires is spraying the burning solid fuels with water and reduce the oxygen content of the atmosphere in the immediate vicinity by introducing an inert gas such as carbon dioxide. Let us look at the Class B fires. Some Class B fires, hydrocarbons, petroleums, and fuels on fire, cannot be efficiently controlled with water. So what to do? Some Class B fires can be controlled with the application of chemical fire suppressants. Let us see Class C fires now. Class C fires are electricity as a continuous power source for plastic cable jackets. These kinds of fires can be effectively controlled by removing the oxygen. Let us see hazards caused by fire. One of the major hazards, major contributing factors of firefighting operations is the toxic environment created by combusting materials. The four major hazards are as follows. 1. Smoke, which is dangerous in synthetic household materials. Oxygen deficient atmosphere. 21% oxygen is normal. 17% oxygen is considered oxygen deficient. Elevated temperatures, toxic atmospheres. So these are all hazards caused by fire. Let us study the second one, that is firefighting, ways and means extinction of the fire. To stop a combustion reaction, one of the three elements of the fire triangle has to be removed. Without sufficient heat, a fire cannot begin and it cannot continue. Heat can be removed by applying water, which reduces the heat available to the fire. Let us look at the fire extinguishers. The two most common types of extinguishers in laboratories are pressurized dry chemical and carbon dioxide extinguishers. Let us see the types of extinguishers. The first among these is water mist extinguishers. These are for class A, that is paper and wood, but not for class B and C fires, such as burning liquids, electrical fires, or reactive metal fires. Now, they are effective on pool chemicals but should be kept away from electrical hazards and equipments. Let's see the second one, that is dry chemical extinguishers. These extinguishers are useful for class A, B, C fires, or B and C fires. They are advantageous than carbon dioxide and clean extinguishers. In this type of extinguishers, a non-flammable blanket can reduce the reignition. The third one, carbon dioxide extinguishers. Carbon dioxide for class B and C fires, or halotron 1 or FF36 extinguishers. These are better than dry chemical as no hazard residue is left. Hence, therefore, this is apt for computer fire or other delicate instruments. The fourth one, foam fire extinguishers. These are more expensive than water, but more versatile and used for classes A and B fires. Foam spray extinguishers are not recommended for fires involving electricity, but are safer than water if inadvertently sprayed onto live electrical apparatus. Let us see the fifth type of these fire extinguishers. Metal or sand extinguishers. These are not flammable metals, class D fires, and they work by simply smothering the fire. The best extinguisher is sodium chloride, NaCl, but these are a variety of other options. The first one, that is sodium chloride. This works well for metal fires involving magnesium, sodium. Heat from the fire causes the agent to cake and form a crust that excludes air and dissipates heat. Let us look at the powdered copper metal for lithium and lithium alloys related fires. Developed in conjunction with the US Navy, it is the only known lithium firefighting agent which will cling to a vertical surface, thus making it the preferred agent on three-dimensional and flowing fires. The next one, graphite-based powders. The graphite-based powders can be used on lithium fires and high melting metals such as zirconium and titanium. Let us see the next one, that is wet chemical. The wet chemical is a specialist extinguisher for class F fires. I am going to the next one, that is importance of firefighting bylaws. What is the significance? What is the importance of these firefighting bylaws? The first one, fire safety bylaws. To ensure safety of such buildings and their occupants, the following bylaws are adopted and duly notified by the Delhi administration of 23rd June 1983. They are further updated in force from 2nd March 1987 until July 2nd, 2010. Importance of building bylaws in residential buildings. Good fire safety management in homes for kitchen, gas and electrical fire safeties. Formulation of fire escape plan for homes, flats, dormitories, hostels and hotels for safe evacuation of the occupants. Mock fire drills should be carried out to avoid panic and confusion for safe evacuation of the occupants. The fire escape plans have to be practiced periodically by the occupants in the form of mock fire drills so that the evacuation of the occupants in the building can be carried out promptly, smoothly and in an orderly manner avoiding panic and confusion, which can lead to accidents and injuries. The exits and stairways should be cleared of all obstructions or hazardous materials. Where residential and non-residential occupancies coexist, extreme care has to be taken in the design and construction of the premises so as to ensure that all essential fire and life safety requirements as per codes are incorporated in the building. The residential occupancy should not have egress pass through the non-residential occupancy in the same building. Interior finishes, including floor finishes in residential occupancies, shall be of approved classes as per relevant codes standards. Lifts, escalators should be of standard approved types as per relevant codes standards. AC plants, high pressure boiler and transformer rooms should not be located under or adjacent to exits. Such rooms, walls should have a minimum of 4 hours fire resistance. Flammable liquids for household purposes should be kept in sealed containers. Low flash inflammable liquids like petrol should not be stored in residences. No stove or combustion heater should be located at the foot of stairs, which may block the escape. Kitchen exhaust ducts, fans which convey hot and inflammable gases and vapors should be fixed to an outside wall or to a non-combustible material duct. All outdoor antennae shall be properly grounded and protected from lightning. Storerooms containing flammable liquids should be posted with a sign on each side of the door in 50 millimeter high block letters stating "Fire door, keep closed." These storerooms should be fire resistant. Let us now look at the bylaws for staircases and lifts. Staircase bylaws. All fire escapes should be directly connected to the ground with entrance separate and remote from internal staircase. The route to fire escape should be free of obstructions at all times except the doorways leading to the fire escape, which shall have the required fire resistance. Fire escape should be constructed of non-combustible materials. Fire escape stairs shall have straight flight not less than 125 centimeter wide with 25 centimeter treads and rises not more than 19 centimeters. Handrails shall be at a height not less than 100 centimeters. Let us now see the spiral stairs. The use of spiral staircase should be limited to low occupant load and to a building height not 9 meters. It should not be less than 150 centimeter in diameter and should be designed to give the adequate headroom. Let us see the staircase enclosures. The external enclosing walls of the staircase shall be of the brick or the RCC construction, resisting fire for not less than 2 hours. All enclosed staircases shall have access through self-closing door of 1 hour fire resistance. These shall be single swing doors opening in the direction of the escape. The staircase enclosures on the external wall of the building shall be ventilated to the atmosphere of each landing. The mechanism for pressurizing the staircase shaft shall be so installed that it should operate automatically on fire alarm system or sprinkler system and be provided with manual operation facilities. Let us now see the ramps. Ramps of not more than 1 in 10 slopes may be substituted, for which requirements have to be satisfied such as enclosure capacity and limiting dimensions. Larger slopes shall be provided for special uses, but in no case greater than 1 in 8. For all slopes exceeding 1 in 10 and where the use is to involve danger of slipping, the ramp should be surfaced with approved non-slipping material. The minimum width of the ramps in the hospitals shall be 2.4 meters and in the basement using car parking shall be 6.0 meters. Handrails should be provided on both sides of the ramp. Ramp should lead directly to outside open space at ground level are courtyards of safe place. For buildings above 25 meters in height, access to ramps from any floor of the building should be through smoke fire check door. In case of nursing home, hospitals, etc., area exceeding 300 square meters at each floor, the ramp should not be less than 2.4 meters in width. Provisions of lifts. Provision of the lifts shall be made for all multi-storied buildings having a height of 15 meters and above. All the floors shall be accessible for 24 hours by the lift. The lift provided in the buildings should not be considered as a means of escape in case of emergency. In case of emergency, grounding switch at ground floor level should also be provided to enable the fire service to ground the lift car. The lift machine room should be separate and no other machinery be installed in it. Let us now see the enclosure or lift. General requirements for this enclosure or lift are as follows. Walls of lift enclosures shall have a fire resistance of 2 hours. Lift shafts shall have a vent at the top of area not less than 0.2 square meters. Lift motor room shall be located preferably on the top of the shaft, separated from the shaft by the floor of the room. Landing door in the lift enclosures shall have a fire resistance of not less than 1 hour. The number of lifts in one lift bank shall not exceed 4. A wall of 2 hours fire rating shall separate individual shafts in a bank. If the lift shaft and lobby is in the core of the building, a positive pressure between 25 and 30 PA shall be maintained in the lobby and 50 PA shall be maintained in the lift shaft. The mechanism for the pressurization shall act automatically with a fire alarm sprinkler system, and it should be possible to operate this mechanically also. Exit from the lift lobby, if located in the core of the building, should be through a self-closing fire smoke check door of 1 hour fire resistance. Lift shall not normally communicate with basement. However, if lifts are in communication, the lobby of the basement shall be pressurized with self-closing door. Grounding switch at ground floor level shall be provided to enable the fire service to ground the lifts. A telephone back communication facilities may be provided and lifts shall be connected to the fire control room of the building. Suitable arrangements such as providing slope in the floor of the lift lobby shall be made to prevent water used during firefighting at any landing from entering the lift shafts. A sign shall be posted and maintained on every floor at or near the lift, indicating that in case of fire, occupants shall use the stairs unless instructed otherwise. The sign shall also contain a plan for each floor showing the location of the stairways. Floor marking shall be done at each floor on the wall in front of the lift landing door. Alternate power supply, alternate backup shall be provided in all the lifts. Let us study a fire lift. To enable fire service personnel to reach the upper floors with a minimum delay, one or more of the lifts shall be designed to enable the fireman in an emergency and accessible to every dwelling floor on each floor. The lift shall have a floor area of not less than 1.4 square meters. It shall have a loading capacity of not less than 545 kilograms or 8 persons in a lift with automatic closing doors. The electric supply shall be on a separate service from mains in a building, and the cables should be safe from fire within lift shaft. Lights and fans in the elevator having wooden paneling or sheet steel construction shall be operated on 24-volt supply. In case of power cuts, it shall be automatically switched over to the alternate supply. Alternatively, the lift should be so wired that during power cuts, it comes down at the ground level, comes to standstill with doors open. The operation of a fire lift should be by a single toggle of 2-button switch in a glass fronted box adjacent to the lift at the entrance level. When the switch is on landing, call points will become inoperative and the lift will be on car control only or on a priority control device. When the switch is off, the lift will return to normal working. The lift can be used by the occupants in normal times. The words fire lift shall be clearly displayed in fluorescent paints on the lift landing doors at each floor level. The speed of the fire lift shall be such that it can reach to the top floor from ground level within 1 minute. Now let us study the fire alarm system. All residential buildings and hostels shall be equipped with manually operated electrical fire alarm system with 1 or more call boxes located at each floor. The location of the call boxes shall be decided at a distance of not more than 22.5 meters. The call boxes shall be of the break glass type without any moving parts, and the call should be transmitted automatically to the control room. All call boxes shall be wired in a closed circuit to a control panel in a control room located as per bylaws, so that the floor number from where the call box is actuated is clearly indicated on the control panel. The call boxes should sound 1 or more sounders to ensure that all occupants of the floor shall be warned whenever any call box is actuated. The call boxes shall be so installed that they do not obstruct the exit ways, and yet their location can easily be noticed from either direction. The base of the call box shall be at a height of 1.5 meters from the floor level. All buildings other than the above, in addition to the manually operated electrical fire alarm system, should be equipped with an automatic fire alarm system. Automatic detection system shall be installed in accordance with the relevant standard specifications. Let us now look at fire controls and prevention. Fire control through material used for construction of building. The combustible flammable material shall not be used for partitioning, wall paneling, false ceiling. Any material giving out toxic gases, smoke if involved in the fire, shall not be used for partitioning of a floor or wall paneling or a false ceiling, etc. Construction features, elements of structures shall conform to National Building Code and BIS code. Let us now see the fire prevention. In addition to the measures recommended above, the following fire prevention measures must be implemented when the building is in occupation. Flammable substances such as diesel, oil, gasoline, motor oils should not be allowed to be stored within the building, within the premises of the building. The only exception to this rule may be storage of diesel oil in a properly installed tank in a fire resisting compartment in the generator room. Diesel oil, gasoline, motor oil, etc. filled in the vehicle tanks. Preparation of tea and warming of food must be prohibited throughout the building. Where heaters are used during winters, the following precautions must be taken. All heaters except convector heaters must be fitted with guards. Heaters must not be placed in direct contact with or too close to any combustible material. Heaters must be kept away from curtains to ensure that the curtains do not blow over the heater accidentally. Heaters must not be left unattended while they are switched on. Defective heaters must be immediately removed from service until they have been repaired and tested for satisfactory performance. Use of heaters must be prohibited in the entire basement, fire control room, and in all weather maker rooms throughout the building where there is profusion of combustible, flammable materials. Use of candles or other naked light flame must be forbidden throughout the building except in the offices for sealing letters only and kitchen. When candles, spirit lamps are used for sealing letters, packets, extreme care should be taken to ensure that paper do not come in direct contact with the naked flame and the candle spirit lamp does not topple over accidentally while still lighted. Fluorescent lights must not be directly fixed above the open file racks in offices, record rooms. In avoidable cases, such lights must be switched on only for as long as they are needed. Filling up of old furniture and other combustible materials such as scrap paper, rags, etc. must not be permitted anywhere in the building. These must be promptly removed from the building. More than one portable electrical appliance must not be connected to any single electrical outlet. Used stencils, ink, smeared combustible materials, and empty ink tubes must not be allowed to accumulate in rooms, compartments where cyclostyling is done. These must be removed and disposed of regularly. All shutters, doors of main switch panels and compartments, shafts for electrical cables must be kept locked. In record rooms, offices and stores, a clear space of not less than 30 centimeters must be maintained between the topmost stack of stores records and the lighting fittings, whichever is lower. Fire detectors must not be painted under any circumstances and must also be kept free from line distemper. Records must not be piled, dumped on the floor. Welding or use of blowtorch shall not be permitted inside the building except under strict supervision according to the requirements laid down in IS 3016-1966 Code of Practice for Fire Precautions in Welding and Cutting Operation. Printing ink, oil must not be allowed to remain on the floor. The floor must be maintained in a clean condition at all times. Well, so far we have seen the major causes of fire and the measures that one should take to fight the fire, bylaws established, bylaws laid down, what are the various fire extinguishers and how to take prevention and precautionary measures to prevent fire in our houses. I hope the session was resourceful to all of you. Thank you very much.